Here's another rational function to try. Step 1, vertical asymptote. That's the denominator. Set the denominator equal to 0. X squared minus x minus 6 equals 0. Factors into x minus 3 times x plus 2 equals 0. So x equals 3 and x equals negative 2 are my vertical asymptotes. Again, I'm going to number my graph by 2's or by 1's. So x equals 3 will be here. That's my vertical asymptote, x equals 3, and x equals negative 2 will be here. That's my vertical asymptote, x equals negative 2. Now we'll check for symmetry. So for symmetry, we'll find f of negative x. That will be negative x minus 2 over x squared plus x minus 6. That does not equal f of x or negative f of x, so no traditional symmetry. Let's find the horizontal asymptote. For the horizontal asymptote, we'll look at, we have a first degree over a second degree. So the numerator is a lower degree than the denominator. That automatically means y equals 0 is a horizontal asymptote. So y equals 0 is a horizontal asymptote. And we need to fill that in. That's my horizontal asymptote, y equals 0. Okay. Next, we want to find the y-intercept. The y-intercept is when x equals 0. So that will be 0. And when x equals 0, I would have negative 2 over negative 6. So it's 1/3 is the y-intercept. So 0 1/3 would be about right here. Now we want to find the x-intercept. For the x-intercept, we need the function to equal 0. And when we do that, it's really the numerator that equals 0. So x, or the numerator x minus 2 equals 0. X equals 2. So 2, 0 is an x-intercept. The next thing we would need to check is to see if it has intersects with the horizontal asymptote. Well, the horizontal asymptote is the y-axis, and we have a y-intercept. So yes, it intersects. Why are my pens being so weird today? Intersects the horizontal asymptote at 2, 0. We've already calculated that. The next thing to do would be to check the points. As we go along the x-axis, we start from negative infinity. The first thing we run into is negative 2. So we need a point between negative infinity and negative 2. Now, continuing along there, we'll go from negative 2 and going on the x-axis. The next thing we run into is this point at positive 2. So we need to find a point between negative 2 and positive 2. And then we need to find a point between, next going along, here's from our positive 2, we run into this vertical asymptote at 3. So we needed to find a point between 2 and 3. And that's the last thing we run into. So we need to check a point from 3 to infinity. Those are the regions where we need to check at least 1 point in each region. If we use, in this region, let's say we say x is -3, then we would have -5 over 9 plus 3 minus 6. 9 plus 3 is 12, minus 6 is 6. So we have the point -3, -5/6. So -3, -5/6 would be approximately here. Now, my graph does not cross the horizontal asymptote in that area, but we know we have a horizontal asymptote and a vertical asymptote. So far, we can go this way and coming down here this way, getting close but not touching. Then we need to check a point from -2 to 2. Well, we've already got this one, but I'm going to, just for grins, also do -1. When I do -1, I have -1 minus 2, so that would be -3. -1 squared would be 1, minus a -1, so 1 plus 1 minus 6, so it would be a -4. So this would equal 3/4. So we have -1, -1, 3/4 would be approximately here. We also need to check, so it looks like we're going from here, and then this is a vertical asymptote. So we'll run up here, getting close but not crossing. We need to do a point from 2 to 3. Unfortunately there, we really need to do 5.5, or 5/2, or 2.5. So 5/2 or 2.5, that would give me 2.5 minus 2 would give me 1/2 for the numerator. For the denominator, we're going to have 25/4 minus 5/2 minus 6. So 25/2 would be 6 1/4. Minus 6 would only have 1/4 minus 10/4. So I have 1/2 divided by -9/4, which is going to be really times 4/9. Cancel, cancel. So this is going to be -2/9. So 5/2 would be halfway between 2 and 3, and -2/9 would be approximately right here. And then that tells me we're going on down here, and this is a vertical asymptote, so we'll come close but not cross. And then we need a point between 3 and infinity, and I would probably just choose 4, the next one. So 4 minus 2 would be 2 over 16 minus 4 be 12 minus 6 would be 6, so 2/6 or 1/3. So 4 1/3 would be approximately here. Notice where that is in relationship to these asymptotes. So horizontally, we'll come close but not cross. A little bit of a curve here, and we'll go vertically, coming close. Oops, should not touch. Come close but not cross. So we really have this curve down here, and we can have kind of a jag through there and a curve across here.